I have already posted few videos on superconductivity. Today also I am going to do the same thing. This is a lecture on superconductivity. Here I am going to discuss the types of superconductors. Only one type I am going to discuss here in this video. There are mainly two types of superconductors available. One is called type 1 superconductor, another one is called type 2 superconductor. Okay, so here in this video I am going to discuss something about type 1 superconductors. Normally, type 1 superconductors, the main problem with this is that this property of superconductivity can be achieved only at very low temperatures. Means it is nearly the absolute zero temperature. The examples are lead, again tin is there. Okay, the critical temperature of lead is 7.2 Kelvin, only 7.2 Kelvin, critical temperature. And critical temperature of tin is around 3.7 Kelvin. So you can see that these two temperatures are very near to absolute zero. Okay, both are used as superconductors. But in all the cases, these materials cannot be used. And for that purpose, room temperature superconductors are being developed by scientists. Okay. Anyway, so here in this discussion of today's lecture, I am going to discuss something about type 1 superconductors. So you know the concept of critical temperature for superconductors. Critical temperature is a temperature below which the property of superconductivity can be achieved and above which the materials won't be able to show the property of superconductivity. So that temperature is called critical temperature. So here I have noted down few points. First point is perfect diamagnetism. You can see everything on the screen. Perfect diamagnetism is required. Means materials which are paramagnetic in nature or ferromagnetic in nature won't show the property of superconductivity of type 1. What is the difference? Diamagnetic materials can repel all the magnetic fluxes when the material undergoes, or if an external magnetic field applied over the paramagnetic materials, then in that case it's diamagnetic. If an external magnetic field is applied over the diamagnetic materials, then diamagnetic materials can expel all the magnetic fluxes from its interior, and that property is required for some applications. And that's why type 1 superconductors are also required. Okay, but if you consider paramagnetic materials or ferromagnetic materials, then in that case the materials are not able to expel all the fluxes. Fluxes means here magnetic fluxes. Okay, so this property is highly required for certain applications. Okay, next is Meissner effect. You know, Meissner effect means same thing. Under the application of external magnetic field, the materials expel the magnetic flux from its interior, and that effect is called Meissner effect. Next point is single critical magnetic field. So here we are talking about magnetic field, externally applied magnetic field. So there is a certain value of the magnetic field strength. Okay, there is a certain value. Of course, it depends upon the material. Okay, for different materials this value is different. The value of the magnetic field strength, it's different for different materials. So there is a certain value of magnetic field strength. If you cross that limit, means if you go above that value, then the materials will transition from the state of superconductivity to the state of normal conductivity. Okay, means superconductors will transition to normal conductors if you cross the limit. Okay, so that limit I am talking about now, magnetic field strength. Okay, whenever you are applying external magnetic field over the material, okay, then the strength of that magnetic field, so about that thing I am talking about right now. So there is a certain value. If you cross that value, if you go above that value, then the property of superconductivity will be destroyed. The material will be converted into a normal conductor in that case. Next point is no mixed state. Yes, for certain materials, mixed states are observed. Not for diamagnetic materials, but for other materials such as paramagnetic materials or ferromagnetic materials, mixed state is observed. Okay, what is the meaning of this mixed state? Means whenever you are applying magnetic, there is a certain value for the given material. Okay, so for lower limit of that value, lower limit of the magnetic field strength, for that value, some fluxes enter into the material and the remaining part of the material remains superconductor. One thing you should keep in your mind that whenever you are being able to expel all the magnetic fluxes from the interior of a material, only in that case that material will be converted into a superconductor. Means in that case only you will get zero resistance of the conductor, and that state of the conductor is called superconductivity. But if you are not able to do that thing, then that is not the state of superconductivity. That is not the state of complete superconductivity. So for certain materials, there is a lower limit of magnetic field strength for which some of the fluxes enter into the material and the remaining part of the material remains in a state of superconductivity, and this is called a state of mixed state. Means it is called mixed state. Okay. And there is one more value, that is higher value of the magnetic field strength, at which you won't observe any trace of superconductivity in that material. That is the higher limit of the magnetic field strength. Next is applications. I have already talked about applications. Okay. In certain cases, complete expulsion of magnetic flux is required, and in all those cases, only type 1 superconductors can be used. Okay. Only type 1. Type 2 superconductors cannot be used in those cases. For type 2 superconductors, you will get this value, you will get this point, no mixed state. I have written here, you will get mixed state. So I am not talking about here type 2 superconductors, only type 1. Okay. So applications, then examples, I have already given you the examples. Lead and tin are the examples of type 1 superconductors. Critical temperature of lead is 7.2 Kelvin, and for tin this value is 3.7 Kelvin. And last is low critical temperatures. Yes, of course, these values 7.2 Kelvin, 3.7 Kelvin, these values are so low. These values are nearly absolute zero, and achieving this low temperature and maintaining this low temperature is very difficult and very expensive. That's why applications of type 1 superconductors is limited. The cases in which you must have to use type 1 superconductors, or the cases in which complete expulsion of magnetic flux is required, only in those cases type 1 superconductors are used. Otherwise, people always try to use type 2 superconductors, where the critical temperature is sufficiently high. So that will be less expensive. Again, that will be less difficult to maintain. In that case, that will be less difficult to maintain the low temperature. Anyway, this was all about type 1 superconductors. Okay. So this is the end of this video. Thank you. Thank you for watching this video.